A statistics professor plans to travel to a conference by plane. When he passes a security check, they discover a bomb in his carry-on luggage. Of course, he is hauled off immediately for interrogation. I don't understand it, the interrogating officer explains. You're an accomplished professional, a caring family man, a pillar of your parish, and now you want to destroy all that by blowing up a plane? Sorry, the professor interrupts him. I had never intended to blow up the plane. So for what other reason would you bring a bomb on the plane? Let me explain. Statistics show that the probability of a bomb being on an airplane is 1 out of 1,000. That's quite high, if you think about it. So high that I wouldn't have any peace of mind on a flight. And what does this have to do with you bringing a bomb on the plane? You see, since the probability of one bomb on my plane is 1 out of 1,000, the chance that there are 2 bombs is 1 out of 1,000,000. You multiply 1 out of 1,000 by 1 out of 1,000. If I already bring one, the chance of another bomb being on the plane is around 1 out of 1,000,000, and I am much safer. So anyways, we're going to address this situation. Did he really change the probabilities of the bomb being on the plane? So that joke is not only funny, it's instructional. So remember, we've already talked about random phenomenons. It's a situation where we don't know what's going to happen. We don't know what the particular outcome is going to be, okay? And the probability of an event is really its long-run relative frequency. So notice the word long run here. We may not be able to predict a particular individual outcome, but we can tell what will happen in the long run. And I think that's what people have difficulties with, is that there's like, oh, I'm going to predict what's going to happen next. You can predict what's going to happen in the long run, but what's going to happen next, we don't know, unless it's an unfair game. So for any random phenomena, each attempt or trial generates an outcome. And as you may recall, we talked about trials and outcomes before, so we're revisiting that right now. The trial's like the experiment, and the outcome is what happens during the trial. Those outcomes are individual possibilities, like the number we see on top of rolling a die, or this Cedar Ridge spinner that I made for us. So you can go to Shodor, and they have these great interactive manipulatives. So I made this spinner, and you can see I've set it. So the Cedar Ridge purple takes up half. Then I couldn't do black, so I did white and silver, or gray, and I set those both to 25%. So based on these areas, you would predict that, let's say I did a total of 4 spins, I would have 2 purples, 1 white, and 1 gray, right? So that's what I would predict. And on 1 spin, I would get a 50-50 shot of getting purple. So let's see what happens when I went ahead and played with this spinner. So here we go. Purple. That's fine. Let's do it again. Purple. Wait a second. I'm at 100%. The next one can't be purple, but it is. Well, not the next one. We won't have another purple. Got another purple. The spinner must be broken, don't you think? Let's try again. Okay, we got another purple. We got 100%. And another purple. 6 purples in a row. Wow. Finally, we got a white. Okay, it'll settle down now. Wait, we got another purple. And then a purple. I thought we were going to get a gray on that one. And a gray finally. So the thing is, this is not behaving very well. Why is that? We've only been doing 1 spin at a time. Now when we start adding more spins, you can see that the percentages are getting much closer to the predicted. Let me add 1,000 spins. And in the long term, yes, I got purple 50% of the time, and the white and gray each about 25% of the time. So it behaved. So the point is, when you're looking at individual events, probability is great, but it's not going to tell you for sure what's going to happen. It will give you a very good rough idea of what will happen in the long term if things are behaving as they should. So this leads us to the law of large numbers. It says long-run relative frequency of repeated independent events gets closer and closer to the true relative frequency. So this example, they say, consider flipping a fair coin many, many times. So that's kind of like my spinner probability. You could get 6 heads in a row, just like I got 6 purples in a row. Is it likely? No, it's not as likely. But over the long term, it behaves. My percentages settled down, and I was getting about 50%. So some common misunderstandings of the law of large numbers is that they're supposed to compensate. So when we were spinning those first few times, I was like, okay, wait, I've had a couple purples. The next one can't be purple. But when we were spinning, the spinner doesn't know what I spun last time. So it has an equal probability of being purple. The probability of being purple doesn't change on each spin based on what happened the previous spin. And here's another example. You know, we tend to think people have hot streaks, right? And you see it all the time in basketball. And they'll say, he's on a hot streak. Give it to him. So they're expecting to get the same thing because they've been getting the same thing before. So it's like, let's bet on purple because purple keeps showing up. Well, they've done some studies of basketball players, and they found out that in actuality, the basketball players' shots, that hot streak is just an unusual streak, just like my 6 purples were. So on the long run, their shots are pretty much hitting the same percentage. And there's no reason to think that the next shot's going to have a better probability because he sunk the last one. Not only that, it contradicts the law of averages one, where, you know, someone said, I've had, there was a letter to Ann Landers said, I've had 7 babies, 7 girls. All right. And the doctor told me I should have a boy next time because I've had 7 girls. And she had a girl. She had a girl. And so she was disappointed because she figured since she had had 7 girls, the next one had to be a boy. And we all think that way. But in reality, what it is the next kid, you never know. It's whatever probability. And if you can let go of the law of averages, which says, you're due now. And we've seen that too. Like people, basketball is like, he's missed it. Okay, he's got to get it now. Well, you got to pick. Both of these contradict each other. It's either he's going to keep getting the same thing or it's got to average out. In reality, neither one works. You do not know what's going to happen during the next event. And so and it doesn't know what you did before. All right. Basketball, you could argue, well, psychologically they could get messed up, but they've done studies on average, it works out. So we'll go on to our next